Ever seen those old movies with someone who's got like a huge lump on their neck, like they swallowed a tennis ball?
Oh, yeah, those goiters.
That's what I'm talking about. And, treating that used to be seriously risky surgery,
Big time.
but then came this big breakthrough,
Yeah.
radioiodine therapy.
Changed everything.
And the whole thing started with a doctor, a lecture, and one of those like aha moments.
Totally.
So today we're going to do a deep dive into the story behind this treatment.
Absolutely.
It's still used today, which is amazing.
Super fascinating story, too.
Full of twists and turns.
Oh, yes. Science, wartime dramas,
Oh, wow.
even a little bit of academic rivalry in there.
Ooh, I love it. Okay.
Have a little drama.
So before we get into all that,
Sure.
just a quick refresher on the thyroid for everyone.
Good basics.
It's that little butterfly-shaped gland.
Right in your neck.
Super important.
Oh, yeah.
It uses iodine to make hormones,
Mm.
and those hormones control your metabolism.
Pretty much everything from your energy levels to your heart rate.
Exactly. It affects so much.
And when things get out of balance,
Wow.
it can really mess you up.
No kidding. So talk about what happens when the thyroid's not working right.
So if it's not producing enough hormones,
That's hypothyroidism,
right,
right?
exactly, you get fatigue, weight gain, even heart problems sometimes.
Oh, wow, that's scary.
And then on the flip side,
Too much hormone.
hyperthyroidism, racing heart, weight loss, anxiety,
Sounds like a wild ride.
it can be pretty intense.
And people have been dealing with thyroid problems forever.
Oh yeah, for centuries.
Like way back in ancient China.
They were using seaweed to treat goiter.
That's an enlarged thyroid, right?
Yep, often caused by not getting enough iodine.
Interesting. So we've been trying to figure this out for a long time.
Definitely. But it wasn't until like the late 1800s, early 1900s that things really started to click scientifically.
Okay, so what happened then?
Well, in 1896,
Mm-hmm.
this guy, Adolf Magnus Levy,
Okay.
he figured out the connection between thyroid function and metabolic rate.
That's huge.
Major breakthrough.
And then just a few years later.
1905.
Okay.
A doctor named Robert Abbe actually used radium to treat goiter.
Radium. Like the radioactive stuff.
The one and only.
Wow. That seems kind of dangerous.
Well, it was an early attempt,
Yeah.
but it kind of set the stage for bigger things to come.
Okay, so this is where our main man comes in.
Enter Saul Hertz
Young, inquisitive doctor.
at Massachusetts General Hospital.
Okay. This is where things get good.
Buckle up.
So it's 1936.
Hertz is sitting in a lecture.
Okay.
The guy giving the talk is Carl Compton, the president of MIT.
Wow, big deal.
Yeah, and the topic.
Uh,
What physics can do for biology and medicine.
Interesting. So what happens?
Compton starts talking about these brand new radioactive isotopes,
Uh-huh.
and Hertz is like mind blown.
Seriously. Just from a lecture.
He was that kind of thinker.
Wow.
He instantly realized, hey,
Uh,
we could use radioactive iodine.
which the thyroid loves to absorb.
Exactly, to target and treat those thyroid conditions.
So it was like a light bulb moment.
Total epiphany.
I could picture him scribbling notes like crazy.
Oh yeah, he was probably going through a whole notepad.
So what did he do next?
He reached out to Compton,
Okay.
and they started experimenting together.
On what?
Well, first with rabbits,
Right.
they used iodine 128.
And how'd that go?
There was a snag, a big one.
What was it?
Half-life.
Half-life? What's that again?
So every radioactive element,
Uh-huh.
it has this thing called a half-life.
Okay.
It's the time it takes for half of its radioactive atoms to decay.
I see.
Now, iodine 128 had a super short half-life,
Like how short are we talking?
25 minutes.
Oh, wow. So it basically disappeared before it could even work.
Pretty much useless for treatment.
So they needed a different kind of iodine.
One that stuck around a bit longer,
Right.
so they needed to get creative.
Makes sense. So what do they do?
They teamed up with some researchers in California.
Okay. And why California?
These guys had access to a cyclotron.
That's a cyclotron?
Imagine a giant machine that smashes atoms together. Seriously.
Yeah, to create new isotopes.
Sounds intense.
It was cutting-edge stuff.
So what did they do with this atom smasher?
They managed to create iodine 130,
Okay.
which had a 12-hour half-life,
Much better.
right? And then even better,
Yeah.
iodine 131,
Okay.
with a half-life of 8 whole days.
Wow, that's amazing.
Game changer.
So finally, they had an iodine that could actually reach the thyroid and do its thing.
Exactly.
So when did they first try this on a human?
January 1941.
That's huge.
Hertz treated his first patient with hyperthyroidism using a combo of I-130 and I-131.
So that's the official start of nuclear medicine, right?
You got it.
Wow, what a moment.
It was a safer, less invasive alternative to those risky thyroid surgeries.
Yeah.
And Hertz and his team documented everything.
Good.
And word started to spread like wildfire.
So it was a big deal.
Huge.
I bet other doctors were fascinated.
Oh, yeah. The Mayo Clinic was super intrigued.
That's a big name.
They sent one of their top guys,
Who was it?
Dr. F. Raymond Keating Jr.
Yeah. To learn from Hertz and his team.
Wow, so radioiodine therapy was really taking off.
It was gaining momentum.
That's great. And Hertz,
Yeah, he wasn't done.
he wanted to do even more with this.
He started looking into using it for thyroid cancer, too.
Oh, wow. Even more possibilities.
Exactly.
But then World War II happened.
Yeah, talk about a curveball.
What happened to the research?
Well, in 1943,
Okay.
Hertz felt that call of duty.
Yeah.
He joined the Navy,
Wow, so he put everything on hold.
had to serve his country.
Right, and what about his research?
He entrusted it to another doctor,
Who was that?
Dr. Earl M. Chapman.
Okay, and what was he like?
He worked part-time at Massachusetts General.
Okay, so Chapman was going to keep things running while Hertz was away?
That was the plan.
Seems pretty straightforward.
Well,
Yeah.
there's a little more to the story.
Oh, I knew there had to be a twist.
When Hertz came back from the war,
Yeah.
Chapman wasn't exactly thrilled about giving up control.
Oh, boy, here we go.
Right place, right time for Chapman, you know.
So we've got this amazing medical breakthrough happening, wartime drama,
Yep.
and now professional rivalry.
Oh, yeah, it gets juicy.
Okay, I am hooked. Tell me more.
Well, we'll have to save that for next time.
Oh, man.
Come on.
But trust me, it's worth the wait.
Okay, fine. I guess I can wait.
We'll dive deeper into this rivalry and how it shaped radioiodine therapy when we come back.
All right, I'll be counting down the minutes.
Stick around.
Welcome back. So last time we were talking about this rivalry that was brewing.
Between Saul Hertz and Earl Chapman.
Yeah, Hertz was the pioneer of radioiodine therapy.
All right.
But he had to leave his research to serve in World War II.
And Chapman stepped in to keep things going.
And I bet he made some pretty significant strides while Hertz was away.
Oh, he did publish some important findings.
So when Hertz came back,
Yeah.
I bet there were some fireworks.
You could say that they both wanted to be seen as the leader in this field.
I can imagine that must have been intense.
It was a real clash of egos.
So how did this rivalry play out? Well, through their publications.
Okay, so like a scientific duel with papers instead of pistols.
Pretty much, they both wanted to publish their findings first.
To solidify their claim to the discovery.
Exactly.
So who won?
Well, Chapman actually finished his paper first.
Oh, wow.
And he submitted it to JAMA,
JAMA?
the Journal of the American Medical Association.
Oh, yeah, that's a big one.
One of the most prestigious medical journals out there.
I bet Hertz was not happy about that.
Probably not. But here's the thing.
Yeah.
The editor of JAMA knew about Hertz's work.
Okay.
He actually encouraged Hertz to submit his own paper, too.
Really?
Yeah, he knew how important Hertz's role was.
Wow, so what do they do? Publish both papers.
That's exactly what they did.
No way.
In the same issue.
Seriously?
Yep, May 11th, 1946.
That's incredible. So in a way, this rivalry actually helped radioiodine therapy.
By putting it in the spotlight.
Exactly. It got more attention because of the drama.
Definitely.
And it legitimized the treatment even more.
Right, because now you had these two big names in the field.
Publishing their findings side by side.
It was a win-win for radioiodine therapy.
Even if Hertz and Chapman didn't see it that way at the time.
Probably not, but their rivalry definitely helped propel this treatment into the mainstream.
That's fascinating. Okay, so now I'm curious, how does radioiodine therapy actually work?
That's actually pretty simple.
Okay.
The thyroid gland loves to absorb iodine.
Right, we talked about that.
So when a patient with hyperthyroidism or thyroid cancer takes a small dose of radioactive iodine.
Usually iodine 131, right?
Yep, the thyroid cells just soak it up.
And then what?
Well, iodine 131 emits something called beta radiation,
Okay.
which basically destroys the overactive thyroid cells.
So it's like a targeted missile going in and taking out the bad guys.
That's a great analogy.
And it doesn't affect the healthy cells around it.
Not really. The radiation has a very short range.
Wow, that's amazing.
It's a much safer and more effective option than surgery.
Which used to be the go-to treatment. So no more cutting people open.
Not for this, at least.
And I bet it's a lot easier on the patient, too.
Absolutely. It's usually an outpatient procedure.
So you can go home the same day.
Yep,
That's incredible.
Yep.
It really is a game changer.
it is.
Okay, so what happened to Hertz and Chapman after all this?
Did they ever become friends?
I doubt it.
Their relationship stayed pretty strained.
I bet.
But, you know, there were other people involved in this research, too.
Oh, right. Like in that letter, Hertz wrote about Rob Lee Evans.
Exactly. He wanted Evans to get credit for his contributions.
Even though they weren't always on the best terms,
It shows Hertz's character.
he wanted to be fair.
Yeah, but Years later, there was some drama surrounding Evans's contributions.
Really? What happened?
Another researcher who worked with Hertz and Evans,
Okay.
his name was Arthur Roberts.
Right.
He wrote a letter challenging Evans's role.
Oh, no.
He called Evans a manipulator
Wow.
who wanted his name on papers even if he didn't do much.
That's harsh.
Yeah, it sounds like there were some big personalities involved in this whole thing.
And they weren't afraid to clash.
Definitely.
It's a reminder that science isn't always this neat and tidy process,
It's messy sometimes.
driven by human ambition and ego.
All part of the story.
But it's still amazing that something like radioiodine therapy came out of all of that.
A treatment that's helped millions of people.
Exactly. So despite all the drama,
The science prevailed.
okay, so back to Hertz.
Yeah, he wasn't just focused on the thyroid.
He had bigger plans for radioiodine.
He thought it could be used to treat other types of cancer too.
Really?
Yeah, he was a visionary.
So what did he do
He started the Radioactive Isotope Research Institute.
to explore those possibilities?
Exactly. He was pushing the boundaries of what was possible.
That's incredible. So sad that he died so young.
Yeah, he had a heart attack in 1950.
Only 45 years old.
A huge loss for the scientific community.
But his legacy lives on, right?
It does. His daughter, Barbara, has worked hard to preserve his work.
That's great. What did she do?
She created a digital archive of all his research and letters,
Wow, that's amazing.
making sure his contributions aren't forgotten.
And the medical community, they recognize his achievements too, right?
Absolutely. The Society of Nuclear Medicine and Molecular Imaging.
Okay,
They created an award in his honor,
that's awesome. What's it called?
the Dr. Saul Hertz Lifetime Achievement Award.
So they give it to people who are doing amazing work in radionuclide therapy.
Exactly. A fitting tribute to a pioneer.
It's incredible to think how one man's curiosity
And a well-timed lecture.
led to such a revolutionary treatment.
It really shows the power of science.
And the importance of collaboration
And a little bit of luck.
always helps.
So what other amazing discoveries are out there just waiting to be found?
It's a question worth pondering,
It is.
and that's where we'll leave things for now. But when we come back, we'll delve even deeper into the world of nuclear medicine.
And explore the lasting impact of Saul Hertz's work.
Stay tuned. So we're back and ready to wrap up our deep dive into radioiodine therapy.
It's amazing how Hertz's work really sparked a whole new field of medicine.
Yeah, nuclear medicine.
Exactly.
It's like he opened a door to using these radioactive isotopes for all sorts of treatments and diagnoses.
And today it plays such a huge role
Oh, yeah.
in diagnosing and treating so many conditions.
It's incredible.
From heart disease to cancer to even neurological disorders.
Wow.
It's gone way beyond just the thyroid.
It's a real testament to how one discovery,
Can lead to so many others.
that ripple effect of innovation.
Exactly.
And sometimes those advancements are way beyond what anyone imagined.
You never know where a discovery might lead.
This whole story with radioiodine therapy,
Yeah.
it's a great example of how science isn't always...
A straight line.
Definitely not.
More like a winding road with detours and roadblocks.
And sometimes you stumble upon something amazing you weren't even looking for.
Those happy accidents.
Exactly like Hertz's lucky lecture.
Right place, right time.
And then the collaboration, the wartime interruption, the rivalry,
All these twists and turns.
it all played a part.
It really shows that science is driven by people.
With all their flaws and ambitions,
It's not always pretty.
definitely not. But sometimes those human elements can actually push things forward in unexpected ways.
Makes you think.
It does, and it highlights how important it is.
To have a strong scientific community.
One that values collaboration, open communication.
And the sharing of ideas.
Exactly like how Hertz teamed up with those physicists.
To overcome that half-life problem.
Right, if they hadn't worked together, who knows if radioiodine therapy would even exist today?
It's amazing what can happen when people put their heads together.
Makes you wonder what other amazing discoveries are out there,
It's just waiting to be found.
waiting for someone to make those connections
Ask the right questions.
and push the boundaries of science.
That's what it's all about.
So as we wrap up our deep dive into radioiodine therapy,
Yeah.
let's remember that sense of curiosity and collaboration.
And to be open to the unexpected.
You never know what you might find.
And that brings us to the end of our exploration today.
We hope you enjoyed this journey with us.
Learning about the science, the drama, and the impact of this incredible treatment.
If you're looking for more fascinating stories,
And deep dives into the world of science history and culture.
be sure to subscribe to The Deep Dive.
We'll be back soon with more exciting explorations.
Until then, keep learning, keep wondering, and keep those curious minds engaged.